Hi guys, and welcome back to this journey towards excellent exam results. In these shorter revision videos, we are going to be breaking down different concepts in geography within the specification. The aim of this is to help us understand the concepts better and to give us the information and confidence we need to answer the examination questions. In today's video, we are going to be talking about the global atmospheric circulation. This is covered in all the GCSE geography specifications. Okay, let's get started. So this is the model that you can see here on the right, and it's also referred to as the tricellular model. And that's because it consists of three cells that redistribute heat from the equator. Okay, so we'll start at the ITCZ, and that is this area here near the equator. Now we can see that the equator is right there, and that there's low pressure at the equator, and that's because of the sun's heat. We said that the insolation is most at the equator. So the equator is the one that heats up the most, and as a result of that, the air warms up, low pressure is created, and the air rises. So as you can see here, this rising air, or the arrows are in red, meaning that the air is warm. Now, generally speaking, we will lose 6.5 degrees Celsius in terms of temperature as we go up into the atmosphere, which means that this air will cool down as it rises, and eventually it's going to condense to form clouds, and those clouds will give rainfall. Now, that rainfall obviously means that these equatorial regions are hot and wet throughout the year. So this air that is up here now that had cooled down and condensed, or well, the air that is up here now is a lot colder. And because of that, it will then have to sink. Now, it will not sink back down to the equator because at the equator there is rising air that is going to block it from sinking down to the equator. And therefore, the air is going to be drawn down towards the tropical regions, which are at around 30 degrees north and south of the equator. Now, as that happens, obviously, because it's sinking air, it's going to cause high pressure in those areas at 30 degrees north and south of the equator. And this is why we actually have deserts around these areas at 30 degrees north and south of the equator. So the areas here are generally hot and dry. And some of the air is going to be drawn back towards the equator, the cold air that sunk down here, and the process is going to repeat itself. Now, that cycle right there is what is referred to as the Hadley cell. So the Hadley cell is revolving or moving heat from the equator towards 30 degrees latitude. Okay, so the rest of the sinking air, however, begins to move towards the higher latitudes here as warmer air in this particular area here, which is at the tropics. We said it's hot and wet, so some of the air now starts to move towards higher latitudes at 60 degrees. Now, as it moves there, it meets with cold air that is coming from the polar regions. Now, when that happens, the two air masses do not mix, but instead the warmer air will rise above the colder air. Now, as that happens, obviously, we know that it's going to cool down like it did at the equator as it rises due to loss of temperature. And it will then form clouds and you will have rainfall. And that rainfall is at, you'll have a high rainfall at a 60 degrees latitude. So that is going to create low pressure there. Now again, the air now is cold up here and therefore cannot sink back down towards 60 because there is rising air at 60, and therefore some of it is going to be drawn back towards 30 degrees. Some of it is going to be drawn back towards the polar regions. But then if we are talking about this one here that is being drawn back to 30 degrees, it means that it's going to create high pressure again at 30 degrees and then be recycled around this area here. And that there again is a ferrule cell. So it's moving temperature or heat from 30 degrees toward 60 degrees north and south of the equator. So The rest of the cold air, we said, is going to be drawn towards the polar regions. And it's going to sink towards the North Pole and the South Pole in the southern hemisphere. Now, when that happens, it creates high pressure at the North Pole. As you can see here, the North Pole has high pressure. And that high pressure means that the North Pole is fairly dry. Okay, so some people say, oh, the North Pole has got ice. So why are you saying it's dry? But the North Pole obviously may have ice there because of its high latitude, meaning that it's getting less insolation, but there's not much precipitation there, and therefore that's why it's sometimes they're referred to as polar deserts. Okay, that's the global atmospheric circulation. That brings us to the end of this video on the global atmospheric circulation. I hope that you have found the information insightful and useful. I have also done a video on how pressure differences and ocean currents redistribute heat across the Earth. It will be linked in the description below and will also pop up as a suggested video at the end of this one. Thanks once again for joining in this journey towards excellent exam results. All the best and see you again soon. Bye-bye.